Good morning. My name is Ruth Clarke and I'm Business Development Manager at Xylem Water Solutions UK. Apologies for not being able to travel to the venue this morning to present. I feel somewhat like an Oscar winner having to pre-record my presentation, but don't worry, I won't be spend 50 minutes thanking people for getting me to this position. This position is based around looking at the use of data to drive operational efficiencies within utilities with a particular focus on smart water networks. Xylem is probably best known throughout the industry for its hardware, so pumps, blowers, UV treatment, etc. But over the last 5 years, we've been moving into the digital solutions space, looking at ways to utilize data to improve how utilities operate. So if we look at the challenges across the water cycle and those that are being faced by utilities today, I guess that we can really look at these in distinct areas, such as water production, where reduction of costs, either in terms of energy usage, chemical dosing, while still meeting regulatory quality requirements without over-treating that water, would be one area. Another would be looking at water distribution, looking at aging assets, increased demand on existing infrastructure, reductions in non-revenue water, reductions in interruptions to supply. These are all hard things to balance within a limited budget. We also could look at the challenges to do with wastewater collection systems, looking at how to reduce pollution incidents, how to reduce internal flooding and non-hydraulic causes of flooding, etc. And then finally, also within the water cycle, we would, the challenges being faced are looking at wastewater treatment, making sure that there's a smoother flow to treatment, regulatory compliance of effluents, while again, reducing those treatment costs. So these challenges are all complex and multifaceted, and being able to find optimum solutions and optimum ways to operate any parts of the water cycle is a really difficult proposition. And as mentioned previously, it's one that's made all the harder with squeezed budgets. So I think as we move into AMP7 and beyond, we will see more and more digital technology being deployed. This in turn will make the need for smarter communication networks more critical. This presentation is concentrating on smart water networks for water distribution in particular, but similar approaches to using data across the water cycle are, of course, in action already today. So what does a smart network really mean, and how do we get there? Well, I think Ofwat acknowledges the scale of the challenge and is calling on utilities to draw on new technologies over the next AMP cycle. Digital technology does offer great potential to the water industry, but just as in other networks, it's really important to understand exactly what smart means in the water industry to avoid it becoming a catch-all buzzword. So let's explore what actually makes a water network smart and how water companies can get there, all within the requirements of AMP7. So what makes a network smarter? For the water industry, a smart network comes down to matching the physical network with digital technology. More data means a company can better monitor, manage, and maintain its network. So a smart network then starts with deploying sensors or smart components across the existing infrastructure. That will then increase the volume and timeliness of data. For example, high and low res, pressure data, flow data, water consumption information, and the status of assets. It is important, however, to avoid simply focusing on gathering as much information as possible. Many companies already struggle with inundation of data, which can provide false positives, which can lead to missing leaks as a result. Instead, to be effective, the task is to identify the signals that matter and determine the actions that should be taken as a result. So cross-referencing of data sets and even applying machine learning can help here. The most critical point about creating a smart network is that it isn't an objective to accomplish, but it's an ongoing process of improvement. So making the network smarter generally involves introducing smart components and IT systems, often gradually, into a huge organization with incumbent systems, processes, and workflows. So this has implications for how organizations both approach individual technology investments and prioritize areas for improvement. To focus efforts on creating a smarter network, it's important to understand how improvements can impact different elements of the water company and the implications for meeting the ODIs and the AMP7. Perhaps the most immediate benefits of smart smarter networks are operational. Teams can identify incidents like contamination or burst pipes to enable maintenance and repairs to take place more quickly, and then consequently to reduce leakage. In the longer term, this data that's being collected can be used to predict network responses. So that would involve moving from a more reactive way of working to a proactive way, and that would bring in the associated benefits of reducing costs, etc. A smart network can also improve water companies' customer relationships, creating more positive dynamics and keeping bills fair. With smart meters, it's possible to empower customers with accurate information about their water usage, to support accurate billing, and to make them a partner in reducing their consumption and helping to preserve water resources. At the top level, accurate data will help companies to demonstrate their achievement of AMP7 deliverables. And finally, in the long term, there's a potential for water companies to use that data, create new revenue streams, such as partnering with insurance companies to offer smart leakage detection discounts or broader smart home management. So the next stage on the smart water journey, the benefits of a smarter network may seem clear, but it's not always that easy to work out the most beneficial next steps on the journey. A plethora of digital projects may have been undertaken already over the years by water companies, which will have mixed success rates, which will have led to creating a quite complex IT landscape. In addition, water utilities have to deal with extensive physical complex infrastructure, sometimes built over hundreds of years and covering thousands of miles. With this in mind, it's best to take a balanced approach to smart projects. To ensure that investments aren't wasted, all initiatives must reflect the overall business strategy and particularly the key ODIs for AMP7. At the same time, it's important to acknowledge that no one size fits all, and it isn't always possible to know how initiatives will work in practice. Taking an initiative approach where projects are prototyped, piloted, and reviews enables organisations to identify and then scale the most impactful initiatives. Of course, the actual technologies chosen will be critical to ensuring the success of each new smart initiative. Given that creating a smarter network is a gradual process of development, it's important that each project involves hardware and software that's both robust in the long term and adaptable for the new initiatives that will follow. Choosing smart components designed specifically for the water industry rather than generic Internet of Things devices can assure their long-term robustness in the water environment, and that they will improve rather than compromise the network's resilience. Equally, selecting components with a longer life will create greater return on investment over time, delivering value for customers and shareholders. It's also important that smart components offer highly accurate water monitoring capabilities. For example, in the case of smart meters, devices that offer accurate, consistent data, even at low consumption levels, will enable water companies to identify and respond quickly to unusual usage or burst pipes. Finally, the communication standard used by smart components are important. Components that offer multiple wireless standards or even wired options can more easily be integrated into the existing network and remain operational as a smart network evolves further in the future. It's also important that data transmissions are secure and encrypted to ensure that the network remains resilient to vandalism or malicious cyber attack in the years to come. Every water company's journey to a smarter network will be different and with its own challenges and complications. By taking an iterative approach to smart projects and choosing components that are robust and adaptable, water companies can begin to realise the benefits of a smarter network, one that meets the needs of AMP7 and beyond. It's important to note that it's very important that data analytics tools should be data and sensor agnostic, so they can be slotted into the existing sensors without the need to replace all current instrumentation. Then, as time goes by, the utility can invest in new technology, new sensors that can be slotted into that existing platform. So data, in general, utilities do have a lot, but I think the question that we need to ask is, are we using it to its maximal potential? And I think the answer to that is going to be a clear no. The first step in using data to improve operations is to see what you already have and know what the problem is that you're trying to solve. Do we have the right data at the right resolution being measured in the right location, and is it being delivered reliably, would be the questions I would ask. This will inform what insights can be drawn from the existing data and highlight data gaps and strategies of how that data is used. Any smart system must be able to take account of data reliability. quality checking the incoming data, for example, to flag up any anomalies. Other key elements of using data to inform on how to operate your network are the ability to present data clearly to operators in a timely fashion, irrespective of how great your system is. If it's not easy to understand by the people working in the operations room, it's not going to be successful. It must provide analysis results on the data streams that can be acted upon. So maintenance or bursts occurred. This information must be very clear to the operators. And it must be able to accurately predict behaviour, which can then be presented, reducing disruption, improving service, and saving money. Smart systems are only useful if they can turn data into action. So for some examples, what information a smart water network can provide from the data being fed to it, it can provide information on the DMA level. It can look at the water balance, which obviously would be more accurate when you've got measured consumption data, of course, to look at how much water is being lost in that particular DMA. It can give estimations of customer side leakage intelligently, so not just that Mrs. Smith is not using or is using more water, but being able to look at each customer within a cohort to see, is something happening weather-wise? It's really hot, everybody's consumption's gone up, or Mrs. Smith always goes on holiday their first 2 weeks in August, for example. Using historic data and cohort data to draw these insights in order to make sure that you can act upon them. It can also give information about meter under registration or incorrect sizing, which will help drive down per capita consumption. It can give information on sensor reliability. Is the sensor behaving itself? Can it be trusted? It can look at data trends where, for example, a leak is growing and could turn into a burst, so that you can go out and do some proactive maintenance before you get into that situation. And it can provide insights derived from multiple data sources. For example, increased flow into a DMA, no change in consumption pattern, increased acoustic noise, and evidence of transients. All of these would point to there being a burst in that location, as well as being able to provide you with some information to narrow in on where that burst has occurred. So it would allow you to look for the cause of the transient as well, and the source can be located, in which case an operations strategy could be assessed or amended. Another really important thing about smart networks is that they must be flexible and scalable. So starting on a journey with a smaller scope of works, if you like, and being able for that to be flexible and scalable. So it must be able to grow with the changing needs of the utility and as more data becomes available. So it needs to be able to have a deeper functionality as well as a wider reach in terms of larger network inclusion. So I think we're at a really interesting and exciting time within this industry, and I think that we all have our part to play in reducing energy, reducing the carbon footprint, and reducing the cost. And I think this type of digital solutions approach and using data to inform on action is really the future of where we're going to go. And with that, I'd like to thank you very much for your attention. I know it's probably quite difficult with this being pre-recorded. I do apologise for not being there in person, and I hope that you enjoy the rest of the conference. Obviously, asking questions is going to be quite difficult. So if you would like to do that, please use the email address that's on the screen now, ruth.clarke@xyleminc.com, and I'd be more than happy to respond to any questions that you have.